Okay, so let's talk about the control structure, the flowchart for control structure. So the control structure divide to three, which is sequential, selections, and repetitions. So the flowchart of it also different. Okay, so for sequential structure, a series of steps or statements that are executed in the orders they are written in an algorithms. Okay, and then the pseudocode mark the beginning and end of a block or statement. So sequential is step by step you calculate. Okay, so you will start from start. Okay, and then you will have an end. Okay, so this is a mask. Okay, make sure you have start and end, and then from statement 1 to statement 2 to statement 3 and so on. And then the sequential structure, the flowchart, how you need to draw is, okay, so you use the progress, the flowchart box. Okay, this is a shape, the geometrical shape for that. So you will start from the statement 1 to statement 2. Okay, so this is sequential structure. Okay, so that is also same with the whole statement. If you want to combine it, let's say you have to calculate the area ix and iy. Okay, so you can combine it with become 1 instead of you break it to 1 and 2. Okay, so the sequential structure trace, so you can see that. Okay, you will start with input length and width. Okay, this is an example to calculate the area and perimeter. So process area equal to 5 times 3 equal to 15, and perimeter equal to 2 times 5 plus 3 equal to 16. Okay, and then this is print the output, area equal to 15 and perimeter equal to 16. So this is what we call sequential structure because it's step by step according to the statement. Okay, other than sequential, then we have also selection structure. So selection allows you to choose between two or more alternatives. Okay, so that is allow you to make a decisions. Okay, decisions made by a computer must be very simple, since everything in the computer ultimately reduced either to 1 or 0, which is true or false. Okay, remember 1 is true, false is 0. So if complex decisions are required, it is the responsibility of the programmer to reduce them to a series of simple decisions, okay, that computer can handle. An example problem, what is selection structure? So for problem 1, okay, you can see that you need to determine whether is profit return capitals or loss. Okay, problem 2, you need to determine whether the number is even or odd when the user key in. Problem 3, determine whether the marks is less than 60, or if less than 60 you will print fail, otherwise you will print fast. Okay, determine whether the speed limit exceeds 110 km per hour. If speed exceeds, then fine 300. Otherwise, the fine is 0. And then you need to display the fine is how much. Problem 5. Determine whether the age is above 12. If the age is above 12 years old, and then the ticket is 20. Otherwise, the ticket is 10. So this one, all you need to make selections to further on the step for a program. So how you going to do the pseudocode? Okay, so the pseudocode is like this. So if you have a if condition, only when the if condition is fulfilled, then you will have this statement, or else you will end the if. Okay, and then let's say this is a if condition, if only one choice. Okay, this is one way selections. So if only fulfill this condition, and then you will lead to this statement, else it will go to false, and then this will end these selections. Okay, so you can see this is a shape on how it goes. So selection structure, okay, just now is one way selections. So now you have if and else, mean you can choose either first option or second option. So how you write the pseudocode is, if this is the condition and then this, or else if not fulfill the first condition, and then it will all go to the second statement. Okay, so you can see that is either true or false. This is for if, this is for else. For the first statement, if it's true for if, and then if it's else for the the second statement. Okay, so you can see that. So pseudocode for nested if means that in if condition, and then you need to fulfill another conditions. So this is the nested if. So what is the if nested if condition? So means that Okay, if you go to the test one, if true, then you need to go to another condition. If false, you will proceed to another false, the false statement. Okay, so this is the inside the if you have another if. So this is what we call nested if within the if. Okay, so if it's true, you will like that. So okay, pseudocode for the if using the if elif. Okay, nested if using the if elif. This is multi-way option. So you will have if elif until the end. Okay, so you will have if, okay, and then in the if you have if, and then you have else, and then you have many things, if conditions. Okay, so this is the first condition. If it's true, you go to this, or else you will go to false. Okay, so inside this statement, then you have another condition. If it's true, then you go to this, and it will go to this. Okay, this one considered as one statement. And for the flowchart, okay, for the selection structure, how you can trace it. Okay, so you read the numbers. The number is equal to 10. Okay, is it greater than 0? So it's greater than 0. So yes. So you will go to this statement. So print category A. Okay. Okay. So you will print category A. And then you end. Okay. Okay. So you key in another number. So you key in 0. So is 0 greater than 0? No, right? Okay. So you will go to category B. So you will print category B. However, after category B, you will go back to print category A. Okay, so you will also print category A and then stop. Means the program end. So make sure you need to know how to trace the selection structure. Okay, and then specifies a block, and then other than the selections sequential structure, you also have the repetition structure. So repetition structure is specify a block of one or more statements that are repeatedly executed until a condition is satisfied. So usually the loops have two important parts. First is an operation that is tested for true false. Okay, so if it's true, it will keep running until it's become a false conditions. So a statement or block that is repeated as long as the expression is true. Okay, so let's see. So pseudocode requires the use of the keywords while. Okay, you have while. Actually, while for pre-test loop means you need to fulfill this condition and then it will run the statement. Okay, so we also have the while statement and the for statement. Okay, so you will learn it in the programming later on. So this is the while conditions. Okay, while this statement is fulfilled, then it will print this statement, or else it will go to the end. So this is the repetition structure for the flowchart. So if you fulfill these conditions, okay, it will go to the body loops. Okay. So pseudocode requires the use of the keywords repeat until for the post-test loop. Let's say you have one thing you want to repeat, and then you need to go to that statement until the condition ends. Okay. So counters can be used to control executions of the loop. So it will increase or decrease each time for a loop repeat, and then must be initialized before entering the loops. So for example, initialization. So you need to have an initialization means the initial conditions. So it is fulfilled, then it will go to the body of loop. If it's false, then it will go to the while. Okay, and then after going through the body of loop, it will have an increment, and then it will go back to here. Okay, it will keep running until it becomes false. You will not become infinity loops because you have an increment. Okay. So for example, repetition structure. Okay, so what is the output for the following flowchart when the input is 4? Okay, you input the number is 4. Okay, so let's see now. So first, read the number is 4. Okay, so initialize result equal to 0, count equal to number. So what the memory is now is number is 4, result is 0. Okay, and then count is 4 because count is equal to number. Okay, and then print count. So what you will have is you will print count. Okay, so your print count now, count is 4, and then count is greater than 0, right? Count is greater than 0. Okay, so if yes, okay, then you go to result equal to result plus count. Okay, so count equal to count minus 1. So what happened here is, okay, result equal to result plus count, means it's 0 plus 4. Okay, and then count is equal to count minus 1, means it's the previous count, 4 minus 1, then you get 3. So when you trace this, later you need to take out the paper, then you can practice it. So you will go back to it and you will keep running. Okay, 3, and then you will keep running, and then you will get the answer, and then you will go to the previous section, and then now number equal to 4. Okay, result equal to 7, and then count equal to 2. Okay, so it will keep running until the count become 2. So you can try this hand tracing at home. Okay, so you see now the count equal to 0. Okay, number equal to 4, result equal to 10. So when you go to the next step, okay, so the count is 0, and then is the count greater than 0? No, right? Okay, no. So you will go to print result. Result equal to 10. So you will print this 10 and then finish. Okay, and then you stop. So repetition structure is letting the user to control a loops. So program can be written so that user input determines loop repetition and used when a program processes a list of items and user know what the number of items, and user is prompted before the loops and their input is used to control the number of repetitions. Okay, so this is how it do, and then it is just like the before. You start and then you have a count and then get the limits. Okay, then if it is 4, then it will end. If it's true, then you will keep print the diagram and then until the condition become false. Okay, so this is the how you do the pseudocode. So you will have a start and then you will have a set and then while this, and then you will read the number. Okay, number 1, number 2, print number 1, number 2, read, repeat, and then it end. So this is an example loop control for sentinel numbers. Okay, so thank you for this slide. Okay, see you again.